Graphing absolute value functions. Actually, I think, you guys, this is part 3. So hopefully you watch the other 2 parts. They were done using the TI Nspire calculator, and we really started to explore what changing the value of A does, what changing the value of H does, and the value of K. I think we agreed that all absolute value function equations come in the form A times the absolute value of X minus H plus K. And if all of a sudden you're going, what the hell is he talking about? Don't give up yet, because this gets really easy, I think. If A is positive, then our function takes the general shape like this, doesn't it? So we say if A is positive, so if A is greater than 0, it has this general shape, doesn't it? If A is negative and A is less than 0 makes it negative, just flips the whole thing over and gives it this general shape, doesn't it? So I think that given that, this is going to get really helpful. And just to make it even easier, we also know that this is true. That if we want to know what this point is right here, it is the point HK. Right? HK. That is to say, H K. So just with some details, we can graph almost anything really, really well. There's a couple little changes, a couple little tricks we have to pay attention to, but I think we're really off to a good start. And of course, if that's true about this function here, then it's also true about this one. The vertex, the corner piece, is also the point HK. The one thing we have to remember that is a little bit tricky is that H is the opposite of what we think it is. So if we have X plus 3, what you do actually is you ask yourself what number makes that equal 0. So X is actually equal to negative 3, right? But K is exactly what we think. Let's do some examples, and I think you'll get good at this really, really quickly. So let's take an example. Let's take an example like this. Y, our equation, let's graph this. This is going to get really easy. Stay with me, please. Is X minus 7 plus 5. First thing we do is we look for this A value, and there is an A value here, and it's just hard to see, but it's 1, isn't it? It's just a 1, and it's a positive 1, so we know, what do we get from knowing that A is greater than 1? Well, if A is greater than 1, we have this general shape, don't we? So if you can tell, I did not draw my Cartesian plane here, so this is not on the 4-quadrant axis because there's a reason. Oh, my God, I did it wrong. Nobody's going to say anything. You were just like laughing at me. I have it upside down. So we know that A is greater than 0, so this thing is facing upward. Sorry. We also know that this point right here is the point HK. Well, H is the opposite of what we think we see here, so we see negative 7. We see negative 7, so H must equal 7. So that tells us this is the point 7. 7 what? 7, 5. 7, 5. So we know that this thing is actually over here somewhere. So if this was actually like that, isn't it? Okay? So let's try another one together and see if this doesn't get really, really easy for you. So let's graph this one. We have y is equal to, I'm going to graph it. Y is equal to the absolute value of x minus 4 plus 1. Again, look at the value of A. There's no number here that we can see, so we assume that it's a 1, because 1 times that would be itself, wouldn't it? So that's A. So A equals 1. 1 is greater than 0. So A is also greater than 0, so we know that this thing does this, doesn't it? Has that shape, right? This is just the general shape of an absolute value function. It actually is very V-like, so this should be symmetrical left and right. And we see here the negative 4. So we're looking for this H value right here, right? Looking for HK. We see negative 4, so we take its opposite, which is 4. And then we take this number here, because it's HK, and we get the 0.41. Not bad, right? Okay, so here's one that's a little bit more tricky. It's a little bit more tricky, but still very, very doable. So let's do this last one quickly, and then let's see where we are. Okay, you guys? All right, so let's page down here, and let's do this last one here. And it's just this. Y equals 1/2 the absolute value of x. So the first thing I'm going to do with this one is I'm going to just rewrite it so I can see. Remember, I care about this. Y equals A times x minus h plus k. So I'm just going to look at it like this. I know we have 1/2 here. and we have absolute value of x, but x minus 0 is just x, isn't it? That's going to help me to get this value right here, right? Plus what? There's nothing at the end, so plus 0, right? So we know that our graph looks like this. Here's the Cartesian plane. We have our vertex at 0, 0. So here's our vertex, right? We know that a is 1/2. It's positive 1/2, so it looks like that, doesn't it? So somebody said, well, that looks just like absolute value of x. So what I would do is I would take some x value that's less than 0, like, I don't know, -2 maybe. So I'll say when x is -2, then we'd get -2 minus 0 is -2, right? Absolute value of -2 is 2. 1/2 of 2 is 1. So that gives us the point -2, 1, doesn't it? And that would make this the point 2, 1. All right? So hope this is helpful. You guys are doing great. Love to hear your comments, and make sure you're subscribed. Thanks.